All right, here are 5 engineering projects that are technically legal but probably shouldn't be. Before we get into it, every single one of these projects are hosted on ForgeHub, which is basically the only place on the internet where you can find full build guides, GitHub repos, and kind of active communities on projects like this. So let's get into it. Coming in at number 5, the Autonomous Drone Swarm. This is where a fleet of drones, anywhere from 3 to 30, flying in formation with no center controller. Each drone is only talking to the ones around them, meaning if one goes down, the rest instantly reorganize and fill the gap. The algorithm they are running is called a distributed consensus, where every drone is voting on where to go and none of them are in charge. The physical side, you're building the drones, wiring up the flight controllers, tuning the motor ESCs. The software side, you're implementing the consensus algorithm and the collision avoidance logic that keeps 30 flying objects from destroying each other midair. The reason this is number 5 and not higher up on the list is it's been done before. Like, don't get me wrong, it's impressive, but people have seen drone shows before. But the higher up we get on this list, the more projects you'll see that you didn't even know were possible. Number 4, and this is where it starts to get into territory most people don't even know exists. Your phone camera sees 3 colors, red, green, and blue. A hyperspectral camera sees hundreds. It captures light across the entire electromagnetic spectrum from UV all the way through infrared in narrow bands. Every material on Earth has a unique spectral fingerprint. The way it reflects light is completely unique to what it's made of. So this camera can look at a field of identical green crops and tell you exactly which plants are diseased before the human eye even sees a change. Okay, so the build is a custom optical sensor array and a diffraction grating, which splits light into its components frequencies. And then for the software side of things, it's a full spectral calibration and classification pipeline. So this is what satellite imaging and agricultural drones and military reconnaissance use, except this is kind of insane that you can build this in your backyard. Number 3, GPS doesn't work underwater. Cameras don't work in murky water. So how does a robot know where it is or what's around it? The answer is sonar. This ROV has an imaging sonar that spins 360 degrees, sending out sound waves and listening for echoes. As it moves through a shipwreck or underwater cave, it's doing 2 things at once. It's building a 3D map of the environment and figuring out exactly where it sits inside that map. All in real time, no GPS, the same technology inside self-driving cars and the Mars rover. Okay, so you're building the pressure-rated hull, the thruster system, the buoyancy control, and on the software side, you're implementing a full mapping algorithm. And this is what ocean research vessels use to map the seafloor, except this version kind of fits in a backpack. Number 2, this device can detect the micro movement of a human chest rising and falling as they breathe through a wall. It can tell you exactly where that person is standing in real time without them knowing. It does this using radar. Specifically FMCW radar, which stands for Frequency Modulated Continuous Wave. Normal radar sends a pulse and listens for the echo, whereas FMCW sends a continuous wave that constantly sweeps in frequency, like a tone sliding from low to high, over and over. By comparing what it sent versus what came back, it measures distance with millimeter precision, and because these radio frequencies pass straight through drywall, wood, and concrete, the wall just isn't a factor. The hardware is an RF transmitter and a receiver circuit with an antenna array. And then on the software side of things, you got a... What is it? Oh my gosh, I forgot. A signal processing pipeline running range Doppler analysis to extract position and motion. So this is what SWAT teams have used in hostage situations, and a student once built it on a breadboard by himself. Coming in at number 1, this project replaces Wi-Fi with a laser beam instead of broadcasting a radio signal in every direction, which anyone nearby can intercept. This shoots a focused, invisible infrared laser from one device to another, across a room, across campus, between buildings, wherever you need it to. The data is modulated onto the beam, turned on and off millions of times per second to encode binary data, and everything is encrypted end-to-end before it leaves the device, with the result being that the link is physically uninterceptable. You cannot tap it without standing directly in the beam, and if anything crosses that beam, even a bird, the system detects the dropout instantly and flags it. A laser diode, telescope grade optics, a fast photodetector, and a precision pointing mount that keeps the beam aligned. So the software side of things handles the modulation, the encryption, and the dropout detection. So this is called free space optical communication. So this is what intelligence agencies have been using, many versions of this for many years, and you can just build it in a lab. All right, so those are the top 5 engineering projects with the most aura. If you want a full breakdown with links to any of the projects, comment the word breakdown in the comment section.